Today we are going to talk about complex or imaginary numbers, and our learning goal is actually the title of the lesson today. We want to be able to add, subtract, and multiply complex numbers. So we should probably give some background information here about what a complex number is first. And I'm sure that it's really been bothering you when you saw the square root of negative numbers. Ever since Algebra 1, you haven't been able to stop thinking about it, because in Algebra 1, when you learn to solve equations by taking square roots, if you ended up with something like this, x squared equals -4, your Algebra 1 teacher likely taught you to say there's no real solution, because there's nothing that you can multiply by itself to get a negative number. So, while your Algebra 1 teacher did not lie, it is true that there is no real solution. But we, in some cases, need to be able to solve those. So, instead of just saying no real solution, we just make up numbers for them. And because we made them up, we call them imaginary numbers, or we also call them complex numbers. So, here's how it works. Whenever you have the square root of a negative number, you're going to factor out a -1 as if it were a GCF. So here, when I've got the square root of -4, I factor out my -1. So I've got square root of -1 times the square root of 4. Now that helps us because we know that the square root of 4 is 2. The square root of -1, however, we've still got that negative. We're not exactly sure what to do with it. We don't want to leave that there. It's just like you don't want to leave a radical in the denominator of a fraction. We don't want to leave a negative inside the radical. So mathematicians a long time ago made up a rule, and that is that we are going to call the square root of -1 I. And we always write it, it's kind of like a Danielian, a script I. It's got the little tail on the end. But that I stands for the imaginary number. It stands for the square root of -1. So now, instead of leaving the square root of -4 like this with that ugly negative underneath the radical, we say we know that the square root of -1 is I. So now we take it one more step and say that the square root of -4 is 2I. So pretty simple. Every time you see a negative under your square root, that means that there's going to be an I that comes out of your radical. So never ever leave negatives under the square root symbol. All right, so example 1, we want to simplify the expression. So this is just practicing dealing with your I's. If you've got the square root of -9, that's the square root of 9 times the square root of -1. We know that the square root of 9 is 3, and square root of -1 is I. So that's just 3I. So quickly, look at B and think about what the answer should be there. Write it down. All right, hopefully, whether you just knew it in your head or whether you wrote it out, the answer should be 5I. Again, the reason is it's the square root of 25 times the square root of -1. This is I and this is 5, so 5I. C, you actually have to do some simplification, because here, when I factor out my -1, the other square root doesn't come out evenly. So 32 I have to break down using my radical rules. So it's divisible by 16. It's 16 times 2. So that's 4 radical 2 times I. Now, this is important, and I picked this for a reason, because it's important the order that you put these in. When you write complex numbers, the standard form is going to have the constant first, then the I, and then the radical. So this answer, when I multiply 4 radical 2 times I, is 4I radical 2. Because things that get to come out of the radical should be in front. So that's why the I gets to go in front of that radical 2. All right, so why don't you try D? So pause it for a minute and work that one out, because that one doesn't come out evenly, and then unpause to see if you've gotten it correct. So first thing I'm going to do is factor out my -1. So I know that's going to give me my I. Over here, 200, the biggest perfect square it's divisible by is 100. So square root of 100 is 10, so that's 10 radical 2 times square root of -1, which is I. Again, make sure you put it in the right order. It's going to be 10I radical 2. And that's our answer there for simplifying. Now, there's a little bit more that you need to know about your imaginary numbers. We call these our special I's. You need to memorize them, especially this one. You are going to see this one over and over and over again. Most people know the first one, that I is the square root of -1. But I squared is -1. Here's the work. I wrote it all out. I squared, well, if I is the square root of -1, the square root of -1 squared, remember to square a square root just takes away the square root symbol. So that's why. I cubed is going to simplify to -I. Again, I've got the work over here. If we know that I squared is -1, then we're multiplying that times I, which gives us the -1. And then likewise, I to the 4th is 1, because I to the 4th is I squared times I squared, which is -1 times -1, which gives you +1. So these 4 special I's you need to know, because we're going to need to simplify using that information. Now, we just recently reviewed radicals, and I said that we treat radicals like we treat variables. You can't add radicals together unless they have the same number underneath the radical symbol. And the same thing is going to be true for our I's. We treat I's just like we do any other variable, except that when we end up with the special I's, we're going to simplify those. So we can solve a lot of different problems, and this, for the most part, takes you just back to the beginning of Algebra 1 and combining like terms. Here, if I've got addition and subtraction, which is what I have in A through D, all I'm doing is taking away the parentheses. When it's a plus, there's nothing to distribute, so I've got 1 plus I plus 2 plus I, and then just combining my like terms. So here are my plain numbers. Here are my I's. When you write it in standard form, it says it's going to be A plus BI. So the I term comes second, the plain number term comes first. So plain number term 1 plus 2 gives me the 3, and then I plus I is 2I. So here you can see how I got that final answer. All right, you try B, pause it real quick, do B, and then unpause to see if you have it right. So I'm going to rewrite. Since it's plus between, I don't need to change any signs. They keep the ones they had. Then I need to identify like terms. So my plain numbers, 4 plus 6 is 10. And my I terms, 2I minus 3I is -1I. Remember, you don't need the 1 in front. It's just 10 minus I. All right, C is subtraction. So just like you did at the beginning of Algebra 1, you have to remember when you have subtraction, it's like distributing a negative. So that becomes -4 plus 3I before you combine like terms. So distribute the negative first, then combine your like terms. So here are some like terms, and here are some like terms. When I write my answer in standard form, plain number comes first, so 3 minus 4 is -1. My I terms, -2I plus 3I is +1I. So -1 plus I is my answer. All right, last one of these, so do D. Again, it's subtraction. Remember what you need to do first, and then unpause to check it. So I'm going to recopy the first one, It's subtraction, so I distribute the negative, minus 5 minus I. So like terms here, like terms here. Negative 2 minus 5 is negative 7. 2I minus I is I. So negative 7 plus I. All right, so we are almost done with all of our learning goals. We got our background information for what I is, and the learning goals were to add, subtract, and multiply those complex numbers. So we just added and subtracted. The only thing left is multiplying. So these ones we're going to be foiling because I've got a binomial times a binomial. So just like you foiled with x's, you're going to foil with i's. The only thing you need to remember is this. If you end up with a special I, you have to simplify it. So let's rewrite our special i's here. I is square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the fourth is positive 1. Okay, so we're going to FOIL all of these. So first, outside, inside, lasts. So F for firsts, first terms, 1 times 2 is 2. Outside, outside terms, 1 times I is I. Inside terms, so these ones right here, I times 2 is 2I. And then lasts for L, last two terms multiplied, I times I is I squared. So you can see I color-coded my FOIL. Now I need to combine like terms and simplify special i's. So I look for my special i's first, and I look here. I'm going to leave these ones the square, we don't need to make those square root of negative 1, but I do need to change this I squared. I squared is negative 1. So this is going to become 2 plus I plus 2I plus negative 1, which is the same as minus 1. So I simplify my special i's, my I squared there. And then after that, now I can say these are like terms here, and these are like terms here. Standard form, 2 minus 1 is 1. I plus 2I is 3I. So 1 plus 3I is my final answer there. All right, let's try another one. So again, it's a binomial times a binomial, so we're foiling it. First, outside, inside, lasts. So firsts, 2 times 2 is 4. Outsides, 2 times 2I is 4I. Insides, negative 2I times 2 is negative 4I. And lasts, negative 2I times positive 2I is negative 4I squared. So first thing I do is identify my special i's. So I've got an I squared here. So that is negative 1. Now it's got this negative 4 next to it. What that really means is negative 4 times negative 1. Now many of you are just going to learn as soon as you see an I squared, you just change whatever this sign was, because negative 4 times negative 1 is positive 4. So in my next step, after I simplify my special i's, this whole term is just a plus 4. So I've got like terms here and like terms here. 4 plus 4 is 8. 4I minus 4I is 0. Those cancel. So that whole thing just gives me 8. This is a peek into why we needed the imaginary numbers, because sometimes we break things down into imaginaries, but when we put them back together and perform operations with them, we can get whole number answers. All right, very last one. I'd like for you to pause it, try it yourself, see if you can FOIL that out and simplify it correctly, then unpause to check. All right, so again, it's a binomial times a binomial, so I'm FOILing. 1 times 3 is 3 for my firsts. Outsides, 1 times negative 4I is negative 4I. Insides, negative 5i times 3 is negative 15i. And then finally, my last, negative 5i times negative 4i, I have to write small here, is positive 20i squared. Again, negative times a negative is a positive. That's why it's plus 20i squared. So next step is to simplify my special i's. So I've got an I squared right here. So since I squared is negative 1, 20 times negative 1 is negative 20. So I've got 3 minus 4i minus 15i minus 20. So like terms here, 3 minus 20 is negative 17. And then like terms here, negative 4i minus 15i is negative 19i. So hopefully you were able to FOIL that and get that correct. If not, correct it on your paper. That is it for today.